Hello, good afternoon, good night, good evening, good morning, depending on where you are. Rafael had some issues. He will be right here with us very shortly. Looks like he joined the previous session. I sent him the right information, so he should be here with us very soon. Uh, so my name is Rodrigo Graciano, and I'm part of the New York Java user group. So for you who are from New York, if you don't know the NY Java SIG, it's the first Java user group ever created, and we have sessions every month. So join us. Looks like Rafael is here now after joining the wrong session.
Oops. Sorry.
I messaged you on Twitter, but you don't read my message, Rafael.
I missed your message. Sorry about that.
No worries at all. So it looks like Rafael is now here with us. Hey Paul, how are you?
Doing well, thank you. Good afternoon, good evening, everybody, or maybe even good morning. Paul Weber from San Diego.
All right. So we have a lot of people already waiting for you in the session. So
Awesome.
everyone, Rafael and Paul. Paul, you're going to present with Rafael together, correct?
Right,
Yes.
yes.
All right. So
Co-presenting.
Rafael and Paul, they will be presenting here the Dux Star Trek Java 19 Challenge, where you're going to learn a lot of things about Java 19.
Yes.
People are saying here in the chat that they love challenges, so
Nice.
that should be a fun session. So without further ado, Rafael, feel free to go on. All right.
Thank you so much, Rodrigo. Okay, so hello everyone. I'm Rafael Donero. I'm here with my friend Paul Weber. He's a judge leader from San Diego. And we are here to give the talk about the Java challenges once again. How are you, Paul?
I'm doing great. It's a great sunny day here in San Diego. Finally got rid of the rainstorms and looking forward to challenging our lucky listeners and audience out there with some interesting Java stuff.
That's amazing. That's amazing. So thanks a lot, everyone, for being here. I know you like challenges, so let's do the challenges. I'm gonna share my screen. Just a minute.
Will we be able to see the audience chat responses? We love the audience to give us some other choices.
Yes, yes. If we can see the answers from the audience, that will be great. Just a moment. Let me share here the slides.
So always the challenge of how do we get these slides up into our StreamYard? No. Hopefully, if you've seen this presentation in the past, we've grown it over the years because the JDK comes out every year. So we've added new challenges and we're up to JDK 19.
Exactly. So can you see the screen, Paul?
I cannot.
Okay, just a minute.
There we go. I can see it now.
Okay, that's awesome. So I'm gonna give you here a brief of what we're gonna present here to you. So we're gonna go from the JDK 8 to JDK 19, and we're gonna present to you the most important concepts for those versions. So stay tuned on those Java challenges, and keep in mind that you don't need to get all of the answers right, because the intention here is to make you learn those concepts. So if you answer the wrong alternative, that's great, because you're gonna learn a new thing, okay? So those are all our Twitter handle, so feel free to follow us. And if you want to download the code, you can go to this link, and then you can learn even more, okay? So, Paul, now you can go ahead.
Yeah, we're warping through space. You kind of saw a little bit of our things going on. This is a little bit of a history lesson back in 96 to 2010, where Sun was kind of doing all the JDKs orbiting. And then we had a spectacular event. Let's see if our animation clicks again.
It did. It did.
And one more time click. See, there we go. We had a anomaly, a big red giant out of that yellow sun came and obliterated all of the close orbiting JDK planets. But as we see, there are many more JDKs coming. And yeah, so some of them are in hyperbolic orbits, meaning they only last for a few months. We're going to start our journey with JDK 8, which is one of our long-term supported JDKs. I think it's still supported. It's quite old, with a general release date of March 2014. So let's go ahead and see what challenges this planet brings us. Okay, Raphael, you want to take the first one?
Of course, I can. So I'm going to just give you a brief about this challenge. So you can see that we are creating a list, and then we are invoking the method pick, limits, and for each with this string. So I want you to look carefully at the code and try to guess the answer. So let's see what are the answers. What are the alternatives?
Oh, I actually hear some of the music. Yeah. Maybe it's just coming over your mic or your headset. Anyways, there's dramatic music playing here for the audience to figure out, is it A, B, C, or D? And this is where, I don't know, Rodrigo, if we could see the chat coming through, have the audience chat their answers out.
Okay, do we have access to the chat so that we can see what the audience is guessing? Can we see what answer, what alternative the audience is giving?
You should be able to see here, but they're saying letter A.
Letter A, okay.
And the next one, C or D.
Okay. All right.
That's good. That's good. We have a good mixture of guesses. Okay, so let's see the answer then. Come on, Duke.
Yeah, well, we'll have to depend on Rodrigo to give us some of the answers.
Okay, great. So I guess most of the audience got it right. So congratulations. So what is the important concepts of a string? You have to, so why do we use strings? Strings are used to manipulate data from a collection. So you can manipulate data from lists or sets or maps. And you can notice that we are using the pick and the limit methods, which are intermediate operation methods. And those methods will be only invoked when there is a terminal operation method. So terminal operation method here we are using for each, but it could be the collect method as well. And remember that nothing will happen unless we have a terminal operation method. So remember that the strings are lazy. So that helps to enhance performance. Okay, so that's a simple exercise, but it's good for you to keep in mind that, okay, in a string, there are the intermediate operation methods that will manipulate the data. The terminal operation method will show the data or manipulate the data in some way, okay? So let's go to the next one. Paul, you can go ahead.
All right, and thanks for the link to the YouTube. You can actually see the chat messages now, but let's take a look at these doors. So very simple, an array list. And we're going to do a for each and system out, hey, and the door number. So let's see some of those answers coming up. So here we go, our 4 doors, A, B, C, or D. And let's see what our audience participation happens. Hopefully this may be an interesting one because we are doing something funny. What is going on here? There's a Lambda. Everybody take a look at your Lambda code. Okay, we got errors, or I guess not a trick question. We got A, C, and B. We're across the board. Okay, go ahead and
that's very good.
push the button.
Let's see then. Come on, Duke.
Duke on his super cycle. His jetpack. Oh, look at that. Compilation error at line 5. Now, why do we think that is happening here? Mainly because we have an external variable inside a lambda, and that's where we need it to be final or effectively final. So yes, you could work around it so you could increment it, but in this instance, it cannot be changed. All right, cool. Hopefully, yeah, we got a few people who threw up C there. That's great. Let's move on to, I think, our next planet.
Okay, so let's see here.
Yeah, warping through space-time, and we come up to Raphael and module structure.
Yeah, so we are in JDK 9. And on this JDK, we had the great update to create modules on Java. And as you can see here, one module is using each other, and we have the structure of those modules on the left. So pay attention on this slide, because we're going to use those concepts in the next one. So this is the challenge. It looks very complex, but it's actually not so much. So we are using the class executor, and this class is in the module reason, and the other module is the Vulkan, and we have the Spot class. And notice that we are using some methods from the Spot class in the executor class. Paul, sorry, but there is a lot of background noise. Okay, thank you. So you can notice that we are using a couple of methods from the module Vulkan. So I want you to try to guess what is the correct alternative. Okay, so notice that we are doing also some reflection manipulation. So pay attention on that. So let's see the alternatives then.
And now we're mixing Star Trek with Simpsons. What's going on here, Raphael? I'm a Star Trek fan. What's this? How Simpsons get in here? All right, we have a first audience. We have C's coming in. Yes, I think I'm the noisy one. Oh, we have a D. Do I hear an E or a B?
Okay, so let's see what's the right answer.
Come on, Duke.
Okay, it's C. So there's some great benefits of using modules. So one of them is that with modules, we have real encapsulation, which means that there is no way to break encapsulation using reflections. And this is different if we are not using modules, because if you're not using modules, we always can break encapsulation. That's bad. So notice that we are trying to use the attack method from the other module. And this method is private, so we can't use the set accessible true. So this is a reflection method, so we can't do that. But notice also that we can use the public the method normally because it's public, so there's no issue on using that. So this error would be different if there was the opens clause, because when we declare explicitly in the module that we are opening this package to be used by the other module, that would be okay. We would be fine to break encapsulation. So modules are good because that breaks down the large Java ecosystem, because the Java ecosystem was a huge monolith, and by breaking the whole Java ecosystem into different modules, that makes much easier for the Java architects to implement new Java features and to evolve the Java language. So the modules concept came in a good time, because it came when now, for example, the Java vendors are releasing new Java versions from 6 to 6 months. So that makes this job much easier, okay? And by using modules, also it helps Java developers to create lightweight applications, because we don't need to use all the Java ecosystem anymore. We just need to use what we are using in our application. So that's useful for mobile apps, for example. Okay, so Paul, you can go ahead. JDK 10.
Blown up. Wait a second. That's one of those short-term JDKs. One thing to note about the JDK 9, that was like the last really big release. There were a lot of things that came into JDK 9. And as we've indicated here, 10 is no more. So let's go off to our long-term support at JDK 11. Well, hopefully our audience is at least on this, if not even higher JDKs. So not to test out your eyes, but this is an interesting one. Var turnabout intruder. So line number 3, take a look at that. Var equal new var. It sounds like Jar Jar, but wait, that's a different genre. But moving on, we have a Dr. Lester. We have a mistake. That's interesting. Let's go ahead. There's only 4 print statements here. Raphael, what did the door say?
Let's see alternatives.
Compilation error, line 4. All right, we got Kirk, Spock, Khan, Borg, and Darth, and a couple more. All right, let's see, audience. Hopefully your tissue computer has compiled this code and executing it to find which of our 4 answers is the correct answer.
Do we have any answer, Paul?
No answers yet. I think we may have stumped the audience on this one. So let's see. Yeah, we got the interface var down at the bottom, and var.collide. Hey, we have one. We have an answer C. Okay, a challenging one to do in real time sometimes. Okay, let's see what Duke says.
Okay, come on, Duke.
He's pretty spastic there. And
it's B.
B, what's going on here? So this is talking about var, which is that new kind of a variable we can stick into Java since JDK 11. And it can be used in a name, as we see. and it's not recommended though. And you have to cast it to null if you want to use it as a type. The lambda var modifier, it's in the line 6 there. You can kind of take a look where we're joining a string. You can use in the var modifier, and we get down to our print statements. Kirk and Spock come out fine. Con, the Borg, and everybody come out okay. And then we get to the turnabout intruder challenges. Yes, that's just the name of a class, of a new class there. I believe, yeah. $1. And then 3.2. Oh, line number 8. There we try to pull a fast one on you, where we have an integer array, I believe, and we're using object identifier so that we can remove that value 1. So 3.2 without the 1 at the end.
Exactly. Another thing that's important to mention is that we can only use var inside the method. We can't use a var as an instance variable. And a var is not like a JavaScript var because it's a type inference instead. So the type we assign to var, it will be the type and that's it. So that's important to remember. It's a type inference. It's not a type like JavaScript.
Very good. Okay, let's see what else JDK11 had for us.
Okay, let's see. So we are now at JDK 12, which is a short-term version. And now we are going to the JDK 13, and it's also another short-term version. So, okay, JDK 14, another short-term version. 15. Okay, so this is Java 15. It's another short-term version, which means that the features can be changed. So it's not a final version. It's not a long-term support version. So it means that there might be a preview version. Okay, so on this challenge, we'll be talking about text blocks. And you can see that in the first variable, Jedi without text block, we are not using text block. And the second string, we are using Jedi with text block. So you can see that the first variable, it's quite verbose. So this is not, it's not a good code to read. It's very verbose and it's quite confusing. You see that we are putting a lot of plus signs in the first string, and the text block makes the code much better, much more concise. So I think that's important to mention regarding text blocks. And you can see that we are using a with equals methods, and we have 2 system print lines. So pay attention to the code, and let's see the alternatives.
We already have an answer. Let's see if it's one of our selections. Of course, it must be. It's a quad box. Okay, we have, let's see, one of our listeners. That's great. One thing to note, as Raphael was mentioning about JDK 15, it is short-term. Text blocks was finalized in JDK 15, whereas there were other previews and incubators going on in the 15. But the 15 itself is long gone, as you know, because we're on 19. But something good came out of that. What a fly Duke there.
Okay, let's see. Okay, congratulations. What's the name of the person, Paul, who got it right?
And that would be Simon.
Simon, congratulations, Simon. That's awesome. Who else got it right? Someone else?
Yeah, Tom was out there. And
Tom,
let's see.
congratulations. And for those who got it wrong, don't worry, because if you got it wrong, you're going to learn. So, okay, so let's see why it's this answer. So here we are using the strip methods. And notice that we are using the formatted method, which will substitute the percentage s with look. But notice that in the Jedi without text block, we're not using text block. Therefore, we are using the formatted method only in the last string, which is the /HTML. So that's why we are not formatting look on the Jedi without text block. And when we use text block, it's only one string. So that makes the code more concise. You create only one string, and it's much better to read. And in the Jedi with text block, it's perfectly possible to substitute the percentage s with look. So that's what we do. And then when we compare Jedi without text block first with Jedi with text block, the comparison will be false. Why? Because in the Jedi without text block, it wasn't possible to substitute percentage s with look. And in the second one, as we use again the formatted method, now it's okay because the string is already concatenated. Therefore, the percentage s will be substituted by look. Therefore, the second comparison will be true. Okay. So if you are using Java 15, I highly recommend you to use text blocks instead of concatenating strings because that makes the code horrible. Okay, so Paul, you can go now. JDK 16.
Yeah. So now the JDK releases are coming up in a nice, orderly fashion every 3 months. So 16, another short-term release, which had here again a smaller set of features being displayed, but also a couple that were in their incubator preview, second preview. And here we have record, which records were finalized within JDK 16. So let's take a look at creating a record commander. And we got a ship string planet name. Good. Seems simple enough. We take a look at our commander and not a ship. What does the main do? That's where we're creating the commander. Record of a new ship and a couple of system outs. Let's see what those doors lead us. So just a simple commander.name. Wow, who's our commander? To take a look at this constructor, things like that. And then we're going to take a look at this commander equals to a new commander. What could actually happen if we're creating a new one with a new ship? Okay. So, do we have any people coming up with an answer? A, B, C, or D?
Do you have any answer, Paul?
I'm thinking. I think that new commander Spock. That's commander.name. First line. What could it possibly go wrong with that one? So now what's the other one? New commander, new ship, equals. Well, it's either A or C, and I don't think a new ship would equal. Let's see what Duke says.
Okay, let's see the answer then.
Oh, look at that. Somebody has come up with see. Let's see if Duke agrees.
Congratulations, whoever it was. What's the name of the person?
Anmu. I
Anu.
hope I
Okay.
got your name right.
Congratulations. Go ahead, Paul.
Sure. So yeah, record with a generic type. That's kind of a standard that came about it, and then a compact form with a canonical instructor. And just hey, here we're just going to construct a commander. But we get down into the nitty gritty of line number 9. So we're creating a new record new ship with the ship name, but the record is not serializable in this instance, which is why it's going to throw the exception on line number 11. We create a new one. And I believe that's it, right, Raphael? There's nothing else that goes involved with.
Yes, so the important points from record is that a record gives us for free a couple of things like the equals and hash code methods, and keeps us getters. And it's also important to mention that records are immutable classes. So, that means that you can't change the data. And yeah, go ahead.
Yeah, I was going to say, this is where you get down to where we all talked about, just small Java objects that need to hold data or, point reference, and you want that to be, like Raphael mentioned, immutable, but also simple. But you want to get all those comparison operations like the hash, get that for free.
Exactly. It removes a lot of the boilerplate code, and it helps you to create more readable code. So it's a very useful feature, and a record is not serializable as well, which means that's why we are getting an exception. Okay, so that's why it's C. Let's go to the next one. So this challenge is the instance of pattern matching. So I'm gonna give you a brief of this challenge, and then you can think about the answer. So notice that we are using something weird here in the first line. It seems to be an 11, but it is an 11. Maybe it's not. So pay attention on that.
Are we trying to give people an eye test here? They got to zoom in on that line?
Yeah, could be. Just zoom in because there's something weird on this 11, okay? And it might not be 11, by the way. So notice that we are using the shoot method, and we're using the concept called overloading. So we are receiving an object in the shoot method, and notice that we are using a lot of Instanceof comparisons. And in the middle of these Instanceof comparisons, we are using pattern matching. So this is a very handy feature as well to diminish boilerplate code. Okay, so we are using a couple of types on the shoot method. So let's see what are the alternatives then, so that you can guess what is your answer.
All right, I hear subtle music in the background. This transporter energy. You feel the energy of the crowd. And I guess one aspect for us to consider, Raphael, is there's a little bit of a delay with our talk going out to the audience and then chatting back. But we do have a response already, D. So somebody is calculating this stuff. It's great.
Do you have any answer, Duke, Paul?
Another D has come up. Oh, we have 3 Ds in a row. This
Nice.
may be too easy for the audience.
That's
we need
awesome.
a disruptor.
So thanks a lot to the audience to engage and interact with the challenges. You are for sure Java challengers. Okay, so let's see the answer. Oh, you're right. What are the names of the challengers for?
Our Simon,
Oh,
Andrew,
congratulations,
and
Simon.
Tom. Right,
Tom,
Tom.
awesome. Congratulations, Simon and Tom. Okay, so as I said before, the first line, it's not a typo. So it's 1 and L, therefore this object is a string. Okay, so actually it's 1 long, and therefore this will be instance of comparable, and this comparable won't be equals 11 type 1 phasor because it's 1 long, 1L for long. And the next shoot method is receiving the value boolean of true, and this primitive true value will be autoboxed to the wrapper boolean class, which means so the boolean wrapper class is also a comparable. If you enter in the boolean wrapper class, you're going to notice that it implements comparable, and that's why this object will be instance of comparable, and it will be false again. And then we are using a new string buffer, but in the end of the string buffer, we are transforming the string buffer to a string. And this string is also comparable, and it will be false because plasma cannon is not the same as 11 type 1 phasor. And then the last invocation, we pass the runtime exception. And if you notice, the runtime exception is serializable object, and that's why it's going to the last instance of condition. And then we are just printing the name of runtime exception. And notice that in the comparable comparison, we are using the pattern matching feature, which means that instead of having to do that very ugly class casting in Java, you just basically declare the variable of comparable, and it will be cast for you automatically. So that's the benefit of using that. And in future versions, there will be even more benefits with pattern matching. Pattern matching is much more than that. So it will bring a lot of benefits for the Java development. Okay, so let's go to the next planet, JDK 17.
Yay, another long-term supported orbit, JDK 17. All right.
Okay.
Look at that. One of the things JDK 17 finalized was sealed classes. And now we're going to test your tissue computers again with taking a look at all of the stuff that's going on with our favorite names from Star Trek. You know, a couple of captains. There's a captain now, Janeway and Spock. But remember, this is the sealed kind of class, sealed interface. And we have these little comments, #A, #B, and #C, #D. Kind of a takeaway, take a look, because that's going to come up, I believe, in our answers selection. So defining some stuff, put our main in there, yes, do your best. And 3 commands coming out. Static void command takes a captain. What could possibly go wrong? So let's see what our selections are. Now, some of the things as you think about this, what is the benefit of a sealed class? You know, you get control over which code is responsible for implementing a sealed interface. More declarative way for your access modifiers. And then support, as we mentioned before, future directions of our pattern matching. So very interesting stuff. Let's see what, well, do we have any audience participation? Now this is slightly different because we have hash, you know, our answers A, B, C, and D all depend on the hash line. And it looks like this class just isn't going to compile. All right, we do have an answer of D. That's
Awesome.
yeah. C, it's all bad. Could it all be bad? I mean, really, Raphael, would we put something that drastic into the challenge?
Only Duke knows.
Let's see what Duke says.
Okay, let's see. Mount Duke.
Okay. Oh, look at that. It is all bad. Okay, now we have to dissect this. Why is it all bad? Could we have done anything to make it work? This is the challenge. So subclasses must be either final, sealed, or non-sealed as a gateway here. Now we have an interface, puts Janeway into the interface. But Janeway, line number 5, is not sealed, non-sealed, or no final modifiers. So therefore it can't be part of the interface. Then we get down into the command of the new captain. Oh wait, anonymous classes must not extend sealed classes. Okay, you just can't do it. And
Yeah.
then, I said, go ahead, Raphael.
Yeah, so the last one is an important concept, and this concept was introduced in the latest Java versions. And this is the concept, one of the concepts of pattern matching. Because the thing is that when you use sealed interface or a sealed class, you have the permit clause, which means that a captain can be either a Saru, Spock, or Janeway, nothing else. So to use a sealed class or interface, it's good for your code design, which means that if you declare, for example, an interface like named as vehicle, and you use the clause permits to permit only a car or a truck, that will be it. A vehicle can be only a car or a truck, which means that by having this pattern matching already declared in your code, you restrict your code. And the more you restrict your code, the better control you have. The better you are able to avoid other developers to, for example, use the vehicle interface and use, I don't know, a hovercraft to try to implement vehicle. If you don't want vehicle to be implemented by a hovercraft, you just used a sealed interface where you enable only a truck or a car to implement this interface. So that's very good. And other than that, you can also use pattern matching in the switch case operation. And that's very handy because, like I said, the interface captain can be only Saru, Spock, or Janeway, right? So if you have those three options, you don't need to have the default clause anymore. And another detail here is that we are using case captain before case Janeway. But as we are using a parent class, a parent interface, it's impossible to go to the third case here, right? So the second case, the third here, the case Janeway, is dominated by a preceding case label Captain Spock. Why? Because as Captain is parent class, parent interface, it will always go to the second case. It's impossible to go to the third one. So that's the explanation of a condition being dominated by the other.
Yeah, and congratulations to Tom, who basically came up with that same conclusion. Now we have an interesting question or statement from Anbu, that Janeway in line 2 couldn't be added to line 2 because of line 5. And so I think this brings up an interesting point. When you seal your class, the classes that you permit must be in existence for the compiler. Is that correct, Raphael?
Must be, sorry, can you repeat the question?
The class, Janeway has to exist someplace in the system for a sealed interface to permit Janeway. It just can't be a random set of characters. It has to be attainable by the compiler.
Yes, in that case, here we are creating the class Janeway here. So
right, on line number 5, we attempted to create Janeway, but because it implements Captain, it didn't get created, so therefore line number 2 doesn't compile. But if we were to create a class Janeway that was correct, would line number 2 compile?
Yes, if it was correct, yes.
Okay. So, and that's the interesting thing. What we're saying is basically it's not because of subclass modifiers, it's because the classes that are permitted must be legitimate classes.
Yes.
Okay, good. Let's go ahead and move on.
Go to the next one. Okay, so this question is about virtual threads. Virtual threads is related to the project Loom, and it's being developed for a long time, and it's a really important feature for Java because it makes Java as performant as Go, for example, that uses coroutines. And virtual threads is pretty much the same as coroutines. So virtual threads, they're not exactly super fast threads, but instead they are threads that they are better managed by the JVM and the compiler. So that's why it makes it more performant. And virtual threads are much cheaper than platform threads, which are the threads that we are used to beforehand. Another thing that's important about virtual threads is that it doesn't change too much. So everything we knew about threads, the old threads are pretty much the same with virtual threads. So that's awesome. We have a lot more performance if we are dealing with lots and lots of threads. And another thing that we have to forget when using virtual threads is to use thread pool, because virtual threads are so cheap to create that it's not even good to have a thread pool, okay? So, okay, I told you a brief, so the important points about virtual threads. So let's see here, let's focus on the challenge now. So I'm gonna give you a brief of this challenge. So we are using the executor service, and notice that we are using new virtual thread per task executor. So we are using this executor for virtual threads. Notice that we are using a sleep method. So we are stopping the execution for 2 seconds, and then we are submitting 2 tasks with Spock and Worf. And then we have a last print ln at the end of this program. So let's see now the alternatives.
Well, we actually got some answers already out there.
Awesome.
Yeah, that is good stuff. So those dashes, though, those weren't in the answer. But we'll see what people say. Oh, we have an A coming at us. And we have to write the chat too. Yeah, there's some discussion about thread sleep. What could that possibly do in our try catch here? Oh, geez, just a try. So, okay. We've got a absolute couldn't be anything except C. Wow.
Okay, awesome. We have this answer.
Yeah, let's see where Duke goes. And don't forget, there's a line 5 and a line 11. How could those help you answer? Where's Duke?
Okay, do you have any answer, Paul?
Do I have an answer?
Does the audience have an answer?
We have one with a dash, Spock, Worf, dash. That was even before we had the doors open. A came through. C came through.
Amazing.
Also depends on thread how fast it works. So, yeah, I think let's see what Duke says, and then we can talk about some of these. How fast do threads work?
Okay, so let's see.
And Duke's coming through.
Okay, it's D. It could be B as well. There was a small mistake here in the slides, but it could be B, yes.
Even with the dash?
See, yeah, there was a mistake here.
We have a mistake in our challenge, Raphael? Is that what you're saying?
Yeah, a little mistake, yeah. So, yeah, just to explain here to you. So inside the try catch block, what's going to happen is that those tasks, they are submitted in a synchronous way. And it might happen. It's very, very difficult, extremely difficult to have to run this program, I don't know, maybe 100, 1,000 or 10,000 times to make Worf be printed first. Then Spock, but this might happen. And right. The thing by using, go ahead.
That's the order of printing out Spock and Worf. It's inconclusive which way they'll come. I mean, within a single run, pretty much Spock will come before Worf, but it is non-deterministic based upon that small sample set. And as you were mentioning, if you run it over and over again, it may come in a different order. What about line 11, though? Isn't line 11 always going to be last?
Yes, so that's the thing about using this try with the executor. That's the good thing to use this new virtual thread for task executor, because by doing that, you guarantee that those submit tasks will be always executed before the last system out print ln. So that's the great benefit of using that. Okay, so that's pretty much it for this challenge. Let's go to the next one.
Oh, we did have a question about where does the virtual thread join the main thread?
Where does this thread join the main thread?
Right. If we've got we have the new virtual thread executor. Oh, yeah. There's the question.
It's gonna happen inside the try catch block. Inside the try block. So at the moment we create a virtual thread, it will be always created inside a platform thread. So which in that case it's the main thread. The main thread is a platform thread. So when we create this virtual thread, it's going to be created inside the main thread. So it's at the moment we create those threads.
All right.
Okay, so let's go to the next challenge.
And It's our final challenge of the day. We're coming up on the end of our hour. At least I think we're the last episode here. And this is the eye test for everybody.
Yes, it's a big challenge. It's not that difficult, but there's a lot of code here.
Right. It's hard to squeeze the challenges down into code line and then show it on a single slide. We saw that earlier. We had 2 slides for the modules. But on this one, we're talking about structured threads, right?
Yes. So this challenge is connected to virtual threads as well. And we have this shutdown on success class. And we have the shutdown on failure class. So those classes are the ones that you should pay attention to solve this challenge. And notice that in the main method, we are printing the results of those methods get best character and get character. So notice that we have just the get data and get McCoy methods where we are using method references, but they are just method references. They're not doing a lot special. So just pay attention on them. So let's see the alternatives.
Yeah. I think we've got yes, Tom identified structured concurrency. Those were the words I was looking for. Thanks, Tom. And we've got a nice one. So, simple answers. What do we got? We got data, McCoy, data. Who could go wrong with data, McCoy, or data, McCoy? Well, there's a small trivial hint on that last one, but we do have an answer C coming up in the chat channel, which is great. So, Raphael, when we talk about the line 13 and line 6, we've got, structured task scope and then the shutdown on failure, both of them, right?
Yeah, so we have the shutdown failure, and we execute those get data and get McCoy methods.
All right. So to me, shutdown on failure kind of means, you're going to turn something off.
It could be.
Oh, okay. What would it be turning off?
I'm not sure. I don't know.
Uh-oh. So we have D. Oh, Robert, thank you. So let's see. Yeah.
Did you have an answer? Did you have an answer from the audience?
The audience participation has got C, D, and now B.
Okay, I like that we have different answers because for sure the audience will learn on this challenge.
Yes. Let's see what Duke has to say.
Okay, come on, Duke, then. Okay, so the answer is C. So why it's C? So the important things here, like I said, the important classes to solve this challenge is the shutdown on success and shutdown on failure. So the first class shutdown on success, what will happen here? So everything inside this try block, so it's going to run within this rule of shutdown on success. And what does that mean? So a developer was using this class for a real world scenario where he wanted to consume different APIs to check the weather. And he wanted to get the response from the weather from those 3 endpoints. And the endpoint that was the fastest from those 3 endpoints would be the final result. So that's exactly what happens with the shutdown on success. So this means that the synchronous methods that finishes first will be the only one that will return the result. So notice that in the get data, we have a delay of 5 seconds, which means that get McCoy will be always faster than the get data method, right? So on this case, in the shutdown success, we will return McCoy, okay? And in the second method, it's the opposite. So this invocation will shut down only on failure. So if there was a failure here, we would return only the so everything would shut down. So, but here, as nothing happens, as the get data and the get McCoy methods work fine, they will return both answers, both results. Okay, so that's it. That's pretty much it about this challenge.
We did have a question that Tom brought up. Is that based upon the shutdown versus the on success? Why wouldn't it be McCoy data? Oh, there we have it popped up.
So yeah, I guess so can you repeat the question, please?
The answer would be McCoy data. Why is it not McCoy? Because McCoy doesn't have a 5-second delay.
Yeah, actually, yeah, sorry about that. There is a slight mistake here. Yeah, Tom is right. The answer is McCoy data McCoy. Yes. We will change that in the next one.
We're going to have to do a code review, Raphael.
Yes.
How important are those? But I think, don't you have something at the end of the consolation prize for everybody, right? Besides the challenges of the brain. So let's go ahead and close out the session.
Yeah. So what we saw here. So we saw concepts from string. So we saw intermediate and terminal operation methods. We saw also some behaviors from external variables. So how they should behave inside a Lambda. So Lambdas are a functional programming concept on Java, which means that Lambdas are supposed to manipulate immutable data. So you can't change an external variable inside a Lambda. Modules, why they are important? Because you are able to really encapsulate the code. You can create lightweight applications with Java because you don't need to import the whole ecosystem from Java. And it also makes a lot easier for Java architects to implement new Java features. So that facilitates a lot the job to implement new features on Java. Type inference, it's not the same as for JavaScript. And it's actually a type inference, which means that you can't change the type of var. So once you assign a value to this var variable, it will be always the same value, always the same type. And text blocks, so instead of concatenating lots of strings, you have only a text block, which makes your code much more concise, records what are they important because it gives you for free. So you don't need to create a constructor, assign the value. You don't need to create a getter. You don't need to create hash code or equals methods. So you can use record and make your code much better. Instanceof with pattern matching. So you can, so instead of doing that horrible class cast, you can just use pattern matching, and you're going to create a variable from the type, and you can use this variable directly. Sealed classes, why they're important? It's important for your code design. And we also used a little bit of pattern matching with sealed classes. And why sealed classes are important? Because you can define what will be the child classes from your sealed class or from your sealed interface. So you have more control on your code, you restrict more your code, therefore you have fewer bugs. The more you restrict the code, the fewer bugs you have, or the more control you have over your code. So that's why it's important. Virtual threads, where you can create threads that are more effective and faster, in a way lighter than platform threads. So it's a pretty new concept, and it's a concept that makes Java a lot better to compete with new languages such as Go. And in the last challenge, we had structured concurrency, where we could have several asynchronous methods, and we could set a rule. So, for example, when the first method is finished to be executed, then this method would be the first one, and the other one would be just ignored. And the other one on fail, if one method invocation fails, everything would fail. So that's good for you to invoke asynchronous methods. You can follow us on Twitter at Rafa Donero and at Captain Weber. And that's pretty much it, guys. I have this present, this gift for you. You can download the Low-Hanging Java Challenges book for free. You can either use your cell phone as a QR code, or
quick, take a screenshot.
Yeah, just take a screenshot, or just get this link. And
the videos will be up on YouTube later on, if not there already.
Probably it's there because it's live stream.
Yeah.
Okay, I can also share the link. If it's easier for you, I can share the link.
All right. Okay. Thank you, Rafa. Thank you, Paul. What a great presentation.
Thank you so much.
It was the last presentation of the day, and we just mentioned Virtual Threads Project Loom. The Java Champions Conference will resume on Monday, 9 a.m. We have Mario Fusco presenting about Project Loom. So if you're interested, that's a great call. Please join us, and thank you very much, everyone.
Thank you, everybody, for your participation. It's been great.
Bye.
Have a great weekend.
Thanks, challengers. Thanks, Rodrigo.
Thank you.